Okay, so I'll be going through experiment 3 before you all go on to experiment 4. This will also include the add-on questions that we are going through. Okay, so some of the things that we'll be looking at, okay, is literally going to answers, things to take note of. So first thing, they said your provided element S. We knew initially that it was a metal because it is a gray solid. Solution T, we know that it was a yellow solution. So if it's a yellow solution, generally we can sort of like suspect that most probably, okay, most prob contains iron 3, okay, Fe3 plus. So these are some of the clues that we already have when we look at the solution and look at the solid. Okay, test number 1. We went through all this already, so I won't be sharing on what the different reactions are. I just want to focus in terms of the answers they're going to look at. So do take note, first thing, whenever you see the term effervescence, okay, you will need to write down the color and the odor of the gas that's formed. So in this case here, when you do this reaction, it's actually acid plus metal. So you know that hydrogen gas is evolved, right? So hydrogen, we know it's a colorless, odorless gas. And hence, the first sentence or the first point I'll write is effervescence of colorless, odorless gas. Next, you need to test and name the gas. So take note, to test the gas extinguishes lighted spleen with a pop sound. So there are 3 main points to take note of when you're writing the test for the gas or the test for hydrogen. Okay, so this test for hydrogen. Take note of the phrasing, test for hydrogen, take note of the phrasing. Okay, some of you mentioned pop lighted spleen or something like that. So take note, that's rubbish. Okay, so extinguish lighted spleen with a pop sound. That's a test for hydrogen. And lastly, because they said you should test and name any gas evolved, therefore the last one you also say that hydrogen gas is evolved. Okay, so that's already 3 marks already. All these are on the gas. So if you're able to write down these observations carefully and write down the conclusion here, actually you're more or less quite safe in terms of the gas writing already. Okay, the next part is really looking at when you add the element S to the acid, what do you really observe? Now, because you know it's a metal plus acid, so I would expect the gray solid to dissolve because why? The metal would be reacting. So don't just write it's a gray solid, you need to write that the gray solid dissolves. So how do you know it's dissolved? You realize that there's lesser and lesser of the gray solid. Next thing, after it dissolves, you need to tell me what color solution that you have. So having the colorless solution, that will be key here. Now, do take note there's no such thing as a white solution. Take note that you will also never use the term clear solution. All solutions are clear, and there's no such thing as also a white solution as well, okay? So no white solutions, no clear solutions. So these are the first 4 marks over here. Next, to one portion of the test, add aqueous sodium hydroxide. So all of you know that this is a test for cation, okay? Once you know this test for cation, you just literally go to your QA sheet and then you just write down the answer. So the first mark goes to saying what's the color of the precipitate formed. Next thing is to say that what happened to the precipitate? It dissolves in excess. So this is another 1 mark. Okay. The other one is once it dissolves, you need to tell me what's the color of the solution formed. So quite a number of you missed out after dissolving what's the color of the solution formed. So you missed out the 3rd mark over here. Next one, same thing, you add aqueous ammonia. This is once again the test for anion. Okay, test for anion. So white precipitate formed. The white precipitate dissolves in excess aqueous ammonia and then form a colorless solution. Now, some of you wrote that it is insoluble in excess. Now, you are unable to decipher because you realize that some of the precipitate dissolved, some of them didn't. So what you could actually do is, for example, maybe after you add aqueous ammonia in excess, you add under here, there are still some solids left. So you're unclear about it, right? What you can do is you can pour away, okay, pour away the solution, pour away until you have a little bit left with some particles again. Then you go and plus more aqueous ammonia, okay, to just confirm to see whether it is able to dissolve or not able to dissolve in excess. Okay, so this is one way, is that if you suspect that it could dissolve in excess, but maybe you didn't add enough aqueous ammonia, or if the starting solid is too much, or the starting concentration is too much, then what you can do is to pour away some of it, Then after that, you re-add the aqueous ammonia again. Okay, so take note of this technique over here. Okay, number 4, to a depth of T at aqueous sodium hydroxide. So once again, this is test for cation. So this is copying once again from the QA sheet, QA notes. So reddish brown PPT formed. Once you see reddish brown, actually you know that Fe3 plus is present. This reddish brown PPT is actually your iron 3 hydroxide. Okay, that's formed now. It's actually iron 3 hydroxide. Then if you look at your spreadsheet, look at your QA sheet, you'll realize that the reddish brown precipitate is insoluble in excess sodium hydroxide. So this is the second mark. So 1 mark for reddish brown, 1 mark by saying it's insoluble. Next, add hydrogen peroxide. Generally, whenever you add hydrogen peroxide, you should take note of oxygen gas. Okay? Many of you wrote that no, there's no observable change or no visible reaction. This is not true. Sometimes you need to the uh, let the reactants mix a little bit. Mix a while. So shake it, okay? Maybe you need to shake it a little bit more. If you realize there are some bubbles forming already, then you can start to take note of it. Now, sometimes maybe 1 cm cube wasn't enough. You can actually add a little bit more. You can add a little bit more, okay, and that will give you the results better. So what you will observe is actually effervescence of colorless, and actually this is also an odorless gas. Okay, colorless, odorless gas. So take note, color and odor, we need to see it there whenever you write the term effervescence, because you need to tell me what's the gas that you're observing. So effervescence tells me that gas is produced. You need to now describe what's the color, what's the odor of the gas. So it comes as a combined mark. Next, this is the test for oxygen. And lastly, you need to identify what's the oxygen. Identify what the gas is, which is oxygen. Okay, so take note, gas relights a glowing spleen. So there is a difference between glowing and lighted. So on top just now, what you used was a lighted spleen to test for hydrogen. For oxygen test, you are using a glowing spleen. So just take note. Okay, next one. So 1 cm cube of T at equal volume of silver nitrate. So silver nitrate here, if you look at your QA sheet, this is to test for chloride or iodide. Now, because the solution is yellow, so many of you, when you did this experiment, you realize, hey, is it a yellow precipitate or white precipitate? So what you could do is you could let the reaction settle down. Okay, look at the bottom. You realize if you see it from the bottom here, okay, you see it from the bottom here, the precipitate is actually white in color. So white precipitate formed. After that, when you add nitric acid, this is to remove uh, the possibility of carbonate. Okay, so in general, we should see that white precipitate is insoluble in nitric acid. This confirms that your confirms white PPT is silver chloride. Okay, so if that is insoluble, it confirms that white precipitate is silver chloride. Now, if there is a reaction, you see effervescence, then that's where you know that it could be a carbonate. So in this case, because it's insoluble, there's no visible reaction, you know that this confirms that the white precipitate is silver chloride. So yeah, you can either write here white precipitate insoluble in in dilute nitric acid, or you can say there's no visible reaction. Okay, so just take note. Okay, next one. 6A, to 1 cm cube of depth of T in test tube, add the same volume of dilute hydrochloric acid, then add a small mixture amount of T. So you realize a small amount of S to the mixture. So you realize for here, there is the reaction of hydrochloric acid and S, which you had at the start, and that's why you got this. Alright, let me write the odorless here. You have this, and you have this, and you have this as well. Okay, so this 4 actually comes from the very first one, test number 1. Okay, all the results are actually the same there. The only interesting one would be more for T here. The yellow solution turns to a pale green or colorless solution. It depends on what you are really seeing there. Most of you should see colorless instead of pale green because this green is very light. It's not easy to see because of the concentration of the ions that give it the green color is very, very low. Okay, so most of you should be able to write the effervescence, gas distinguished lightest fluid pop sound, gas is hydrogen. You can also tell me that the gray solid dissolves. Okay, now this time there's no colorless solution. If those of you who wrote colorless solution, okay, it's actually not correct. Actually, it is not correct totally. Okay, because you are supposed to take note that it's possibly turning pale green as well. Okay, so don't always assume that it will turn to colorless. Always see what is the reaction mixture that you are having at the start. Okay, so your solution turned pale green or colorless, that's a mark that many of you did not get. So just take note of this. The last one here, for N equals sodium hydroxide, you know that this is test for cation. So all you need to do is just do the experiment and then you take a look at the results. You realize that you got your green precipitate formed, and that's insoluble in excess equals something. Okay, so total there are 24 observations. You just need to write for me 21 and get all 21 marks ready. Okay, you're going to write down your corrections for the things. Now, in terms of the questions wise, identify element S. So S then is actually zinc here because of test number 3. So test number 3 and test number 2. Actually, you can look at 2 and 3. Okay, but 3 is the confirming test. Okay, 3 is the test that really helps you confirm that it's zinc. Because why? From test 3, white precipitate is formed, dissolves in excess equals ammonia. This, you must write down where is it from. You must tell me what's your observation. Okay, from where, what's the observation, and then in the end, this is the conclusion. Okay, so there are actually 3 parts here. Where's the test you're looking at? What's the test you're looking at? What's the observation that you have? So although you have written down at the start, you need to rewrite it here. And lastly, you need to state what's the conclusion from the test and observation. Okay, 2. The cation is in T is +3, Fe3 plus, and then ion in T is Cl minus. This is actually from test 4 and test 5. So this is actually deduced from test 4. This is deduced from test 5. Some of you say, Cher, I thought it's Fe2 plus, right? Question mark, right? Why is it not Fe2 plus? Because test 6 is where you think it's Fe2 plus. However, do you realize that test 6, you have done something first before you did the cation test. So this thing here actually changed the cation. So you cannot say that you see green PPT means confirm Fe2 plus. You need to follow through the experiment, get a sense of what's happening. Okay, don't just straight away say green PPT Fe2 plus. Then I also ask you how come you never tell me Fe3 plus. Okay, so to know what's in T, you should have T plus just the cation test and T just plus the anion test and nothing done before that. Okay, so just take note of it. Question 3, write the ionic equation with the state symbols. So this is just like this. Those of you who are not so strong in ionic equations for now, there's actually a cheat way of doing it. So how I can actually do this is like, I know that it's FeOH3. Okay, so this is on the basis of you know what's the chemical formula of the product. So I know iron 3 hydroxide, FeOH3, is a solid precipitate form. If this is a precipitate reaction, what I know is it will be Fe3 plus 3 OH minus. So you need to know what's the ions that make up your FeOH3, right? So sorry, I got an extra line over here. Okay, then I know that if it's a precipitation reaction, the final product is a solid. The 2 reactant before that must be in the aqueous state. So you can realize that it's like a reverse engineering kind of writing. Another ionic equation they could have asked you to write is based on test 5, okay, 5A. So test 5A, let's say if they ask you to do for test 5A, what you could actually do is you know that formation is AgCl solid. So AgCl solid is made out of Ag plus and Cl minus. Okay, so Ag plus must be equals at the start, Cl minus must be equals at the start. Otherwise, you cannot have precipitation reaction as well. So this is another possible one they could have asked you to write with the state symbol. Okay, last one. Suggest the role of S in test 6A. So what you know is that T initially contains Fe3 plus. After you let S react with the T, suddenly at the end it became Fe2 plus. So Fe3 plus become Fe2 plus means that this is actually a reduction. So what did S, okay, what did S do to T? Sorry, what did my S do to T? Okay, where's my thing, man? Oops. Oh no, what happened to my things? Is there a possible way to undo this? Uh-oh. Never mind lah. So let me just rewrite this whole thing again. My apologies. Um, don't know why there's always all these things here. Okay, sorry, let me rewrite the thing. So T initially Fe3 plus. I let it react with S, right? Then I know that the result is that Fe2 plus is formed. So I know that from Fe3 plus to Fe2 plus, this is a reduction. Hence, S must have, F has reduced T. So therefore, S acts as a reducing agent. How do you know? Okay, because of all this, right? Because first thing, you know that when aqueous sodium hydroxide is added to in 6B, green PPT form, it shows the presence of A2 plus. So you realize that it's a very same format. You first write down from where do you get your test from, what's the observation, and then what's your conclusion, right? Now, only when you say that Fe2 plus is present, then you can finally say Fe3 plus is reduced by S to form the Fe2 plus. So I repeat again, only after you wrote that S is reducing agent, you know that the Fe2 plus is formed, they can finally conclude that the Fe3 plus in solution T have been reduced by S to form the iron 2 ions, the Fe2 plus ions. Okay, so just take note of this. So this is for practical 3. Then I just want to go through the add-on experiment that I gave you guys in terms of the planning. So for this one over here, and for this one over here, let me make this. Okay, so planning questions, all of you have read through already. I just need to take note. This one, they say plant fertilizers contains ammonium nitrate. Upon warming, okay, with aqueous sodium hydroxide, they produce ammonia gas. So take note, you need to warm it in order for the ammonia gas to be able to form. And they say that the ammonia gas is actually which is extremely soluble in water. So ammonia is extremely soluble in water. This clue tells you that cannot use displacement of gas, displacement of water to collect ammonia. Okay? They say you are given 10 grams of plant fertilizers, describe a method that can be used to determine percentage by mass of ammonium nitrate. Then they say you can assume what apparatus used normally found in the lab and stuff. This is quite a standard statement. Standard, you typically tend to see this. Now they say in your method, you should note any assumption. So it tells you that you must write down assumptions, include any measurements you would take. Okay. And then how you use your result determine the percentage by mass of ammonium nitrate in the plant fertilizer. So I know at the end, I want to find percentage by mass of ammonium nitrate. So what I'll do is, I know the approach. I'm going to use what I call the gas collection method to find volume of ammonia. Once I got volume of ammonia already, then I can actually use it to go and find other things. So from the volume of ammonia, I'm going to find the mole of ammonia. How to do this? I'll divide by 24. Now take note, in order for me to divide 24, this volume of ammonia must be in dm cube. Then what's the next step? Once I found the mole of ammonia, I can find the mole of ammonium nitrate. Okay, how to do so is using mole ratio. And what's the mole ratio here? 1:1. Once I found the mole of ammonium nitrate, I'm going to find the mass of ammonium nitrate. Okay, and how to do this? I'll multiply by the MR of my ammonium nitrate, NH4, NO3. Once I found the mass of ammonium nitrate, then tada, I can reach the MA. So from the mass of ammonium nitrate, I can find the percentage of mass of ammonium nitrate in the fertilizer. Okay, so this using the percentage mass formula. Okay, so these are the steps. So to be able to do the calculation, you must be familiar with your mole as well, lah. So those of you mole is not so strong yet, okay, just take note of the steps that we usually take. Okay, now, so in terms of what to take note of, okay, let's shrink it down. Okay, so to here, um, I just want to highlight where am I marking the things I'm looking out for is always the same. So it's a Q, M, A, C. The first A is apparatus, AP. This one is assumption, AS. So where am I looking at the thing? So 1 grams of plant fertilizer, this is the Q. So I use 1 gram of plant fertilizer. The electronic balance here, this will be the apparatus. Okay. As I set out the figure as shown over here, do take note, I'm looking out for the heating here. The heat here will form part of the method marks. Okay, the method of how you go about doing it. Okay, so set up apparatus as shown, what you see here. Do take note in terms of make sure you label your diagram. Okay, don't just draw. Okay, next step 3, react the plant fertilizer. Excess. Okay, sorry, excess. Should cancel this one. Excess sodium hydroxide. This is another quantity mark because it's always one of them is limiting, one of them is excess. So in this case here, the sodium hydroxide is the excess reagent. And you need to gently warm it. So this is where the metal mark comes in. Next, collect the ammonia gas produced from the reaction using a calibrated gas syringe. So this calibrated gas syringe is another apparatus mark. Then reaction is complete. The reaction is complete when there's no further change in the volume of gas. You're going to record the volume of gas collected. Okay, so this whole part from the first one to the fourth one, this is actually overall the method marks as well. So we will see in terms of how you do the setup, how you write the procedure in terms of the flow as well. So step 1 to step 4 will help you get marks in terms of the Q, M, and apparatus. Okay. Now, then the next one will be assumptions, okay, and conclusions. Conclusions generally is the calculation part lah. Okay, so if I look at assumptions first, so assumptions is that 1 mole of gas collected occupies 24 dm cube. Why is it so? Is that actually this is normally collected at RTP. If we are looking at in Singapore, the temperature is actually not at 20. It's actually not at RTP. So that's why this is actually one assumption you're making. The other one is no other ammonium-based substance is present. All ammonia gas produced is from ammonium nitrate. Because if let's say there's ammonium sulfate, there's ammonium other ammonium-based substances, it will produce more ammonia gas, which will affect the results. Okay, so these two are the assumptions over here, which then I covered. Then the last one is really step 5 to step 8. This is actually the calculation of how you reach your conclusion. Okay, so this is the conclusion part. So all this, you realize, is whatever that I mentioned here from step 2 to step 5. So take note of the way how I go about writing this. Okay, P mole, Q mole, R grams, S percentage. So all of this over here is just the way how I phrase it and write it as well. So just be careful or just take note of it. As you do this more, you'll get a hang of it lah. That's one thing I can say. Okay, please feel free to find me if you got any questions as well. So that's all for this one. Thank you, everybody. Thank you.